Hi, this is Mike Power, President and CEO of Silver Range Resources, and this is an update on our Tree River project. First, a quick word from our lawyers. Tree River is in Nunavut, Canada's northernmost territories, and it's about 100 miles south-southeast of Coppermine or Kuluktuk, right close to the Arctic coast. The property is currently about 40,000 hectares and 3 prospecting permits. It's accessible by fixed-wing aircraft from either Kuluktuk or Yellowknife, in the winter on boards or in the summer on floats. Should something significant be found here, we're only 20 miles south of the Arctic Ocean, and it would be possible to service this area by barge. So that's where we are, and that's what it is. What's so interesting about Tree River? About one-third of all the gold that's been mined to date comes from one giant mega deposit in South Africa. This is the Witwatersrand. Since mining began there in the 1800s, geologists have been arguing about what it is. Is it a giant placer deposit? It's conglomerate hosted in a conglomerate formation that's very extensive. Or could it be an epigenetic deposit that came later? Or maybe something else. And furthermore, is it unique? Might there be another Rand-sized deposit out there somewhere? Well, the Wits 2.0 hypothesis suggests there might be, and it provides a clue as to where it might be hiding out. Let's have a look at it. From the formation of the Earth about 4.5 billion years ago until 3.0 billion years ago, the Earth's atmosphere was a toxic mixture of nasty gases, methane and some various acidic gases. And in such an environment, gold was highly soluble in groundwaters, both in sea and fresh waters. Now, in modern times, gold is insoluble in surface waters, both seawater and freshwater. So something changed, and that changed between 3.0 and 2.7 billion years ago. Now, what happened? Well, the change in solubility is related to the development of oxygen in the atmosphere. The first whiffs of oxygen triggered a massive gold deposition event when the solubility of gold dropped from very high levels to very low levels, and gold fell out of solution. So this hypothesis suggests that the Rand might be unique only in terms of its timing, and there might be another one out there. Let's take a detailed close-up view of the Wits 2.0 hypothesis. 3 billion years ago, cyanobacteria evolved. This is blue-green algae or pond scum, and it liked beachfront property, hanging out in a shallow marine environment where sunlight could penetrate, but below the wave base. There it formed extensive algal mats. Here's what one of these might have looked like in detail. You'd have cyanobacteria developing on top of a mat of dominantly anaerobic bacteria. Cyanobacteria are capable of photosynthesis, so these algal mats create oxygen. They're an oxygen-making machine, and the oxygen would likely dissolve immediately into the seawater adjacent to the algal mat. So you'd have a region near the algal mat where you had a higher concentration of dissolved oxygen. The rest of the seawater would have almost no dissolved oxygen. As you recall, there was none in the atmosphere at that time. But it would contain a lot of gold because gold would be highly soluble in such waters. Now, as the reduced seawater circulated through one of these algal mats, it would encounter the dissolved oxygen, and immediately the solubility of gold in that seawater would drop precipitously, and gold would begin to be deposited near the algal mats. This is what you find in the Witwatersrand, where gold is found with carbon leaders in the conglomerate. Now, there's a little more to the story than just a simple algal mat creating gold. Seas rise and fall. There's transgressions and regressions, and these algal mats would get ripped up and incorporated into large conglomerate units. Some of the gold might be aggregated to form nuggets, and much of the gold might remain as very fine particles distributed throughout the conglomerate. So this is a great theory for explaining what might have happened in the Rand. Could it be used as a model to find gold elsewhere? Is there any other gold out there somewhere in the world that formed in a similar environment that could verify the Wits 2.0 hypothesis? Well, there is, starting with Australia. In northwest Australia, in the Archean Craton, deposits similar to the Witwatersrand have been found. They're mid to late Archean, same age as the Witwatersrand. They occur above a volcanic sequence in similar setting to the Witwatersrand, and the gold is hosted in conglomerates, often with very spectacular nuggets you can see here. However, there's also primary sulfides precipitated in situ. This is important because the sulfides would also drop out when the solubility of the seawater changed with the introduction of oxygen. The gold is associated with carbonaceous layers, and these are interpreted to be fossil algal mats. They're common in the Witwatersrand, and they're found in the Pilbara. And the gold occurs in both nuggets, which you expect from the reworking, and in finer grains, perhaps from the primary deposition in algal mats. Now, where might there be another? Well, about 3.0 GA, the Earth's geology looked a little like this, and there was an inferred supercontinent, Atlantica, located here. On one side of it, you find the Rand and the adjacent Pilbara deposits, now separated by plate tectonics, along with several other very old cratons, on which you might find deposits similar to the Rand. On the other side of Atlantica, over here, there's another arm, and on that arm are also some of the older pieces of the craton found now in North America, including Tree River, which was found here on an ancient seashore. So let's take a closer look at Tree River. Tree River is found in the Slave Craton, arguably the oldest craton in North America. In fact, down here near Acasta Lake, there are gneisses that have been dated at 4.5 billion years old. They're the oldest rocks yet found on the face of the Earth. Tree River up here is lying on a younger sequence of basement rocks, about 3 billion years old. The package consists of volcanic rocks with overlying sedimentary sequence. It onlaps the ancient 3.0 billion year old basement and is part of the approximately 2.8, 2.9 GA Central Slave Cover Group. So it's the oldest sedimentary rocks lying on the ancient cratonic basement. Zooming into the Tree River area, we find a mafic volcanic sequence shown here in green, sitting on top of the basement rocks. Overlying it is a conglomerate unit, shown here in orange. This is the Tree River conglomerate. In the property area, it's been traced for about 12 kilometers. It's 20 to 30 meters thick, and there are snippets of it further south over quite a distance. Since it was discovered by BHP in the early 1990s and further explored by Strongbow, it's been determined that this formation carries gold. The background concentration is about 0.1 grams in grabs along its length. And there are higher grade spots with best grabs of up to 142 grams per ton and channels up to 3.5 meters at 63 grams per ton reported in the historic data. Here's what it looks like. These are some slabs that were cut, polished, and examined by Strongbow in the early 2000s. The Tree River conglomerate is a largely monomictic quartz pebble conglomerate formed in a shallow marine environment. It was preliminarily dated at between 2.9 and 2.7 GA, and last year we confirmed that the conglomerate is actually dated at 2.9 GA. So it's right at the front end of the gold oxygenation event. What you find in the conglomerate are primary sulfides, including pyrite or arsenopyrite, some metallic mineral identified as perhaps stibnite, and you find evidence that these sulfides have been deformed like little pillows. So they were primary sulfides deposited in a intertidal environment and deformed by soft sediment deformation. There are also carbonaceous seams. Up to 5% of these conglomerates contain carbonaceous material that we interpret to be ancient algal mats. Silver Range acquired the Tree River project in 2018 and began work that summer. Following up on excellent work performed by Strongbow Exploration, we examined the Tree River conglomerate and sampled two zones, the main zone and the west zone, with best results of 114 grabs from the main zone and 14 grabs from the west zone. Along its length, the average of spot grab samples from a suite of about 88 rocks was about 0.2 grams. This is from just the low-grade samples, cutting out all the high-grade ones. So this demonstrates to us that the conglomerate is gold-bearing along its length. We weren't very happy with how the grab sampling worked out. It was delivering spotty results, and determined that panel sampling might work best. In April of last year, we returned to Tree River and we tried panel sampling at 2 locations. We took 1 meter by 1 meter panel samples with an electric saw and drills, and recovering 50 kilograms from each location. Best results were 36 grams per ton from a panel sample at the main zone. To us, this suggests that the mineralization we see at Tree River is truly primary conglomerate-hosted mineralization and not some sort of epigenetic overprint. Here's a map of our results from the 2018 brief summer exploration program. The interesting thing we find is that the gold in the conglomerate is fairly extensive over several hundred meters at the west and the main zone. Found this quite interesting. And as I said before, the average of grabs along the conglomerate was about 0.2 grams. And if that wasn't interesting enough, in April of 2020, we got a call from researchers at the University of Alberta and learned there was something else at Tree River. Diamonds! In 1997, Val Jackson was mapping for the Northwest Territories Geoscience Office at Tree River, conducting regional mapping, and she took a sample for zircon analysis. Now, regional mappers do this to date a formation. They recover the rather heavy zircons and can age date them, and that gives you a good idea when the formation was actually deposited. The sample was sent to the GSC laboratory in Ottawa, and when the results came back, they noted that they'd found a diamond in the same sample. Well, this is exciting news, but unfortunately, the diamond got lost. And without money to follow this story up, this became something of wistful beer talk amongst regional mappers. And that's the way it stood until about 2018. Researchers from the University of Alberta flew back up to Tree River, and they collected 2 10-kilogram samples from the same area where Valerie had collected her samples. These were from the base of the Tree River conglomerate, the same level of the conglomerate that hosts gold. They recovered 3 octahedral diamonds from these 2 samples, one of which contained a olivine inclusion that clearly indicates these are of lithospheric origin. Here's where the diamonds were recovered. Up here on the north end of the Tree River conglomerate, they're just off the Silver Range prospecting permits. They're on Inuit-owned lands. Silver Range has been in discussion with the Kitikmeot Inuit Association to acquire the mineral rights on this ground, and that's in progress. So, what do we have at Tree River? Well, similar to both the Witwatersrand and the Pilbara, we have a Mesoarchean quartz pebble conglomerate. It's sitting on top of much older basement rocks. It was deposited during the Great Gold Deposition event. Remember, we've dated this at 2.9 GA. There are carbonaceous seams present, which we infer to be ancient algal mats. There are also primary sulfides present with soft sediment deformation. Our sampling has shown that all of the samples below 2.5 grams average about 0.2 grams, so there's widespread gold throughout the conglomerate. Finally, we found a couple of zones with very high grades. So what's next at Tree River? Well, we would like to systematically sample the Tree River conglomerate along its length, collecting large panel samples to accurately determine the gold content of the Tree River conglomerate and perhaps locate some additional high-grade zones. We want to see just how big this thing could be and what its gold endowment might be. To do so, we've initiated permitting, and we hope to have a program underway perhaps in the summer of 2021. So that's it. We're looking forward to getting back to Tree River, finding out just how big this is. Thanks.